All right, welcome back, math fans. This is another edition here of our probability section. So last time, in the last video, we talked about independent events and then multiplying them together whenever we were trying to get two things to happen or more than two things to happen. These are the ones we looked at, and I'm just going to continue on for the bottom half of this page as we talk about dependent events. So just remember the difference between independent and dependent that we talked about last time was for independent events, the results have no effect on each other, right? So like in this one, for example, if I flip a coin and then flip another coin, well, the outcome of the first coin has no effect on the outcome of the second coin, right? And so those are independent events. Dependent events are when they do have an effect on each other. So that's what we're going to look at in a few examples here. So we still multiply these together, even if it's dependent events. You just have to make sure you set up your fractions properly. So when you set up your second fraction, you have to take into account what happened in the first fraction or what happened in the first event. So as we look at this, so what's the probability of taking two cards from the same deck and getting two kings? Right, so notice I am essentially reaching into a deck of cards, taking one out, and then I'm going to reach in again and take out another card. Right, well, as you reach into that deck the first time, right, there's 52 cards in the deck, 4 of those are kings. Right, there's 4 kings in a deck out of the 52 cards. So as I reach into that deck of cards, there is a 4 out of 52 probability of me getting a king. Right? The second event now takes into account what just happened in the first event. So if I took out a card, right, well, now there's going to be one less card in the deck. Okay, so there's only 51 cards now remaining for me to choose from, and take into account what we're aiming for here. My goal is to get kings in both picks, right? So in this pick there were 4 kings. Well, if I take one of those out, if I actually get a king in this first event, what's now the probability of me getting another king? Right? So now there's only 3 left in the deck for me to pull a king from. Okay, and so you kind of have to consider the top and the bottom as far as what's being affected here. So we said on bottom, we started with 52 cards, but since I took out a king, now there's only 51 cards to choose from. And since there were 4 kings to begin with, now there's only 3, assuming that I got a king on my first pick. All right, so if I multiply those together, which is going to be a nice big number for us, obviously a 12 on top, and we would get 2652 on bottom. And so, of course, we could probably reduce that, or, a lot of times when you start getting into big numbers like that, it's probably even makes more sense to even turn it into a percent or a decimal. So if we actually took a look at this happening, so 12 out of 2652. So this is a super, super small number, right? If I'm going to turn this into a percent, I actually move the decimal 2 places over to the right. So if I move it 2 places to the right, this is the percent. It's not even half of 1%, right? So this is less than 1% chance that I would reach into a deck of cards and pull out 2 kings. So extremely unlikely that would happen. So anyway, let's move on to this one. So this is where we're going to get into a tree diagram to answer some questions down here. This is going to be our final question, so we're going to kind of put all this together. So we have a bag that contains 3 red marbles and 4 blue ones, so 7 total. And we're going to make a tree diagram that represents taking out 2 marbles, and then we're not going to replace them. So out of the bag. That's supposed to say out of the bag. As I was reading that word, I was like, what is that saying? So 2 marbles out of the bag without replacement. Okay. So let's get our tree diagram going here. So we have 7 marbles in the bag, and they're either going to be red or blue. So as I reach into the bag and take out my first marble, right, my options are either red or blue. So I'm either going to get the red one, or I'm going to get the blue one. So let's label those. So this is our first event, and it's either red or blue. Let's put in the probabilities that go with that, right? So I have 3 red ones out of the 7, and I have 4 blue ones out of the 7. So 3 out of the 7 are red, and 4 out of the 7 are blue. So this is our first event. I'm going to reach into the bag, and these are my probabilities of getting either a red marble or a blue one. So in the second event, now I'm going to reach in and take out another one. And here's your key phrase, without replacement. That means whatever happens here, I am not going to put that marble back before I reach in and take out another one. So now my second event is now definitely going to be affected by whatever happens here, right? And this is why these are dependent events. Okay, and so let's go up this branch first. Okay, so if I reached into the bag and pulled out a red one, well, as I reach into the bag again, what could happen? What are my chances here? So as I reach into the bag again, it's either going to be red or blue. So it's still red or blue. But look at the branch we just went down, right? So this is, if I pick out a red one, then this is what is going to happen next. Okay, and so consider now there's one less red marble in the bag. So my probability of getting another red one has to drop, right? And so it was 3 out of 7, but now there's only 2 red ones left in the bag, and there's only 6 marbles left in the bag, right? Because 2 of them are red and the other 4 are blue. So what if I got a red one on my first event? What's the probability of me getting a blue one on my second event? So as I look at this branch, so if I got a red one on the first one, right, well now there's only 2 red ones left out of the 6 remaining marbles, but there's still 4 blue ones in there out of the 6 marbles, right? Because this is following the branch where I got a red one on my first pick. And so this is what's left. You'll notice if you do this right, these should always add up to a whole number, right? 2 6 plus 4 6 is 6 6. Just like this little family right here, right? 3 7s plus 4 7s is 7 7s. So every little family within the tree should always add up to 1, right? So let's get one more branch here. So what if I reached into the bag on my first one and got a blue one? What's left? So as I reach back in, it's still either going to be red or blue, but now there's one less blue marble in the bag. So there's still 3 red ones out of the 6 that are left, but since I got a blue one on my first pick, now there's only 3 out of the 6 remaining marbles that are blue for that one. So here's kind of the outline of the tree. The best thing to do from here is now to multiply from left to right. So we're going to look at our possible results here of getting 2 marbles. So it could have been red, then red. So that was a possibility. It could have been red, then blue. It could have been blue, then red. Or it could have been blue, then blue. So these are the 4 possible outcomes, right? This is our sample space of what could happen. The probabilities for those we get just by multiplying from left to right. So if I did 3 7ths times 2 6ths, we're looking at 6 out of 42. If I did 3 7ths times 4 6ths, I'm looking at 12 out of 42. That guy times that guy is again 12 out of 42. And across the bottom, 2 blue ones is also a 12 out of 42. So if we did this right, what we should get is these should all add up to 1 again. So if I add all these together, it should add up to 42 out of 42, right? Which they do. So if you did 6 plus 12 plus 12 plus 12, you're looking at 42 out of 42. So that takes care of our sample space and all the possible outcomes that we could get. So now let's take a look at the questions that follow. So what's the probability that both are blue? Well, we already figured that out right here. It's 12 out of 42. What's the probability that the first one is red and the second one is blue? So that's this description right here. The first one is red, the second one is blue. We also got that one figured out, is 12 out of 42. what's the probability of getting at least one red marble, right? At least one red. So that's these three right here. All right, so all we'd have to do for those is simply add up the winning options. So if I did this plus this plus this, what's that up to? 30 out of 42. And we got our probabilities. Let me just mention one last little side note here and we'll close out the video. Complement events, remember, is subtracting out an item from one. So just like they're saying, what's the probability that you get at least one red? That was those guys. I also could have flipped it around and said, what's the probability that I don't get blue and blue? What's the probability that I don't get this scenario, right? And so if I would have done 1 minus the piece that I don't want, that also would have given me the same answer. And so you can just do the straightforward approach and just add up the winning options. But you do have a choice. If you want to use complement events, the other route is to simply subtract out what you don't want from one, and what's left over should be what you do want, which would be your answer. So that's it for 10.2.